Okay, this video is to kind of help you get started on any review questions that you might need help with. Okay, when we look at number one, this is a parallelogram. And so what we need to think about is what is the area formula for a parallelogram? And you can look at your resource sheet. You will have that on your test. It is base times height. And remember that base and height have to meet at 90 degrees. So when we see this 90-degree angle, that tells us that's what we're looking at. So our base can be 11.8. The height is 16.1. Okay, and we multiply. And then for your perimeter, you're going to add up all of your sides. So remember that whatever this side is, the opposite side is also. So this slanted side is 18.5. So you're going to add those four sides together. Looking at number two, okay, this is a trapezoid. And you're going to need to think about your trapezoid formula, your area formula. Look at your resource sheet. If you can't find it, it is 1/2 times the height times base 1 plus base 2. Okay. Now remember that our two bases are parallel to each other. So when I look, I see the bottom and the top. Those are the parallel bases. Oops. So for base 1, I'm going to use 27. For base 2, I'm going to use 19. And then when I do my math, those will be added together. The height is what connects them, meets them at 90 degrees. So right here, my 90 degrees tells me where my height is, and the height is going to be 16 centimeters. Okay. Now for the perimeter, again, we're going to add all sides. Add all sides. Okay, so we've got our 27 and our 19. We already said we're the top side and the bottom side. We have the slanted side on the right that is 21 centimeters, and the slanted side on the left that is 16 and a half. All right, this is a triangle. You need to think about the area formula for a triangle. Okay, again, if you cannot find it on your reference sheet, you need to be looking. It is 1/2 base times height. Again, the base and the height must meet at 90 degrees. This little dotted line says if I drop straight down all the way to where the base would be and make a 90-degree angle, that is 14. So my height is 14. Over here, this dotted line says if I extended this out to where that make sure that it meets the height at 90 degrees, this side length is 29.5. That is the base length. Don't forget about the 1/2. Um, for the perimeter, we don't have enough information because we don't have that third side. So we're gonna skip it. Okay. Last, we have a circle. The area formula for a circle is pi times the radius squared. I need you to remember that the radius starts in the middle of a circle and goes to the side. The diameter goes all the way across. So for the radius of this circle, it is going to be half of what the diameter is. All right. Now, for the circumference, we haven't used this one a ton, but your formula is on your formula sheet. There are two options. You can say circumference is pi times the diameter. Honestly, I would just go with that. We've been given the diameter here, okay? Pi times the diameter. Your pi key is on the right side of your calculator. It is the second function of your little caret or exponent key. You're looking for this, and then there's a pi above it, and you got to hit the blue second key first. All right, looking onto the back. A square has an area of 49 square miles. What are the side lengths? What is the perimeter? Again, for this, you're going to use your area formula for a square, which is that area equals side length squared. You're going to plug in what you know and solve for what you don't. Remember that the way that we undo squaring is with a square root. Those are inverses. Okay, for number 6, we have a triangle. It says the area of the triangle. That means I'm going to need to think about my area formula for a triangle. The area of the triangle is 216 square feet. What is the height of the triangle? So you are going to use your area formula, which is that area for a triangle is 1/2 base times height. You are going to read your problem. You are going to plug in things that have been given to you. You are going to solve for the height using inverse operations to solve an equation. All right, write an expression to represent the perimeter of the rectangle. All right, so perimeter means that we add all the sides. Now, this one, we aren't given numbers for the sides. We're given some algebraic expressions, but we know how to add algebraic expressions. Okay, right now I've just marked 2 sides. I need you to think about the fact that there are 4 sides. How do you do that? Okay, if the perimeter, oops, is 30 meters, what is the value of x? Well, you're going to have an expression that represents the perimeter. And now you've been given a number that it is equal to. So you're going to set up that problem and solve for x. Okay, lastly, what are the length and width of the rectangle? You're going to know x. Tell me what the length and width are. Solving a problem. You can do it. All right, number 8, we're writing an expression to represent the area of this trapezoid. So we need to use our trapezoid area formula, which is area is 1/2 times the height times base 1 plus base 2. Remember that bases are parallel to each other and they're not the same length on a trapezoid, and the height connects them at 90 degrees. Okay. Inside your parentheses, you're going to be adding. Remember what kind of terms we can add, they must be alike. Then we're going to multiply. We're going to multiply the height times our simplified expression in there. And don't forget the 1/2. You're using your polynomial rules. You're going to be writing an expression. It's going to have x's in it that represents the area. All right. The points A, B, C, and D form parallelogram A, B, C, D. Find the area and perimeter. These have already been graphed for you. Okay. You're going to have to think about for the area of a parallelogram, remember that our area formula is base times height. Base and height must meet at 90 degrees. Look for easy things that can tell you 90 degrees. For the perimeter, you're going to add all sides. Remember that our slanted sides, we are going to have to calculate. I think the easiest way to do it is with our Pythagorean theorem, right? If this is A and this is B, this is C, you might also use the distance formula. That is up to you. If you use the distance formula, it is like this. It's on your reference sheet. You can look it up, but it is x1 minus x2 squared plus y1 minus y2 squared, all inside your radical. Okay, if that's hard to read, look it up in your notes, look it up on your resource sheet, or solve for the hypotenuse of a right triangle. On to the next page. Okay, so now we've got some compound figures. All right, so you're going to need to recognize what your shapes are. You've got 2 triangles and you've got a rectangle. Okay, so triangles are in blue, rectangle I've kind of shaded in purple. Remember that these tick marks, if they have the same number of tick marks, that means the sides are the same length. So if this right here is 5.5 feet, what does that tell you about this side? If this side is 3.2 feet, what does that tell you about this side? Okay, same with these right here. So you're going to find the area of your rectangle. And remember, for a rectangle, it is base times height or length times width. For a triangle, it is 1/2 base times height, and base and height are always meeting at 90 degrees. All right, number 11. Again, we have a triangle and a rectangle. So you're going to find the area of this triangle. You're going to find the area of this rectangle. Okay, you're going to add them together. Notice from here to here is 12 feet. From here all the way to here is 30. This is 8. Make sure you're thinking about how do I figure out the length from here to here. Okay, then we have shaded regions. Remember, we find the area of the whole entire thing and then subtract the part that is not shaded. So we have a square and we have a circle. So you're going to have to find the area of the square using area as our side length squared and find the area of the circle using pi times the radius squared. Remember, the radius goes halfway through, the diameter goes all the way through. Very last one, we have a rectangle as our total area, right? So our rectangle, and for our area, it is base times height. And then we have some squares that have been cut out. Notice that the squares are all the same size. We know that because they all have one little tick mark. Those are all the same. You should also notice that this space between the squares is the same length as the side length of that square. Okay, so you need to think about, how do I know how big the squares are? And then you take your whole thing, you subtract what you cut out. Remember, a square is side squared. So make sure you're working through this. Work carefully, write down all of your process. The answer key will be posted to Canvas at the end of the day.